Hello everyone, myself Pranit. Let us discuss about introduction to the raster scan display. A raster scan display is a fundamental technique in the computer graphics where the image is informed by sequentially illuminating the pixel on the screen. This approach allows for the efficient rendering and output for the flexibility to display the widely range of the digital content from the simple graphics to the high resolution image and videos. So rasters can display a rectangular array of points or dots of pixel. One dot or a picture element of the raster. It intensively range of pixel depends on the capability of the system. Pixel based representation, pixel grid, color depth, resolution. Pixel grid raster display represents the image as the grid of individual pixel of each with its own color and intensity value. Color depth, the number of the number of the number of bits used to represent the each pixel color determine the availability color created and overall image quality. The density of the pixels per unit area or resolution so affects the level of detail and sharpness of the display image. System bus scan line approach, sequential scanning and raster display draw the images by sequential illuminating pixel following the horizontal scan line from the top to bottom, and refresh rate of the display must be continuously refresh the image at a high rate and maintain the stable and the flicker free visual precision beam positioning. Because control the electron beam and or light source is required to accurately position and illuminate by each pixel in the correct location. Frame buffer memory. Frame buffer memory organization. The frame buffer is dedicated to memory area that stores the image data to be displayed on the screen. In memory layout, the organization of the pixel data in the frame buffer, such as row, major, column, major order, affects the efficiency of the memory accessed and display updates. Memory bandwidth. The availability of the memory bandwidth determines the rate at which pixel data can be read over the frame buffer and displayed. The frame buffer e-display processor is shown in the figure. Frame buffer and memory organization. Frame buffer. The frame buffer is a dedicated to memory area that stores the image data to be displayed on the screen. Memory layout, the organization of the pixel data in the frame buffer such as a row, major, column, major order affects the efficiency of the memory access and display updates. So memory bandwidth, the availability memory bandwidth determines the rate at which pixel data can be read from the frame buffer and displayed. Here the frame buffer e-display processor as shown in the figure. Rendering techniques, rasterization, shading, and texture mapping. Rasterization is the process of converting geometric primitives such as the lines and polygons into a set of illuminated pixel shading algorithms determine the color and intensity of each pixel based on the factors like lighting, material properties, and surface normals. Texture mapping is the technique of applying 2D images or pattern to the surface of 3D models to enhance the realism. So, Aliasing and anti-aliasing. Anti-aliasing is shown in the figure. Digitalize and jiggles. Aliasing. Aliasing refers to the jagged or the staircase-like appearance of the diagonal lines and edge in diagonal lines and edge in the raster images caused by the discrete nature of pixel. Anti-aliasing is the technique such as the super simple sampling and filtering used to smooth out these geometries and improve the overall image quality. Improve the overall image quality trade-offs. Implementing the effective anti-aliasing often involving the balancing visual quality, computation complexity, and resource requirement. Here is the diagram shown anti-aliasing diagram, analog line and digital line. Analog line can be converted into digital line. No? And performance consideration, no? And SD resolution. Here you show SD resolution. Higher resolutions require more pixel to be redundant, increasing the computational load and memory requirements. And refresh rate. Maintaining the high refresh rate, typically 60 Hz or more, is essential for the smooth and responsive visual experience. Visual experience. Hardware isolation. Detected dedicated graphics for processing unit can be significantly improve the performance of a raster-based render task. Is shown in the resolution of the thumbnail. Applications and limitations of the raster scan display in computer graphics and uh, versatile display. Raster scan display are widely used in a variety of applications, from computer monitoring and televisions to mobile devices and projections. Scalability challenges. As display resolution and the pixel densities continue to increase, the computational and memory requirement for the raster-based rendering can become a limitation. Emerging technology, newer display technologies such as the vector-based display and the holographic system may offer advantages in terms of the image quality, resolution, and efficiency. Thank you.